All right, so the review for the Chapter 7 quiz, sections 1 through 3. All right, so number 1, we need to find the same base. So if you look on your blue card, they're both going to have the same base of 3. So 3 to the third power is 27, and then we just put the 2x minus 4. And then 3 to the 1 is 3, so this is just 5x. At this point, we can get rid of this. To save space, I want to just distribute the 3 right now. So that's going to give me 6x minus 12 equal to 5x. I don't know why I just rolled 50. All right. You have two choices here. You can subtract 6x or subtract 5 and add 12. Doesn't really matter. You're going to get the same thing. I'm going to subtract 5x and move that over and move the 12 over at the same time and just get x equals 12. If you would have subtracted 6x, you would have gotten negative 1x equals negative 12, divided by negative 1, and there you go. Again, the beauty of this is you can, if you want to spend the time, you can plug this in here and run the numbers in the calculator and confirm that that is correct. I'll tell you I did, because, you know, I make mistakes. You see me do it. I took the time to do 3 to the 60th and 27 to the 48 minus 4. Sorry, 24 minus 4, which is 18, and confirmed that they were the same number. So you've got the time, you've got the technology, it can't hurt. Now, there's two ways to do this one. Well, actually, there's only one way, sorry. You cannot use 4 as a base. Yes, 4 goes into 16, 4 squared, but you cannot do 4 for 8. Because there is no number that gets to 8 with an exponential, just a multiplication, a factor. You can't do 4 times 2. We're not doing multiplication. We're doing exponentials. All right? So this is going to be 2 to the 4th power is 16. 2 to the 3rd power is 8. That's your first step. Now, this has the x plus 1. This has the 2x plus 4. Again, to save space, I'm just going to do the distributing. So 4 times x and 4 times 1. 3 times 2x and 3 times 4. I'm going to subtract 4x, which will give me 2x. I'm going to subtract 12, which will give me negative 8. And when I divide by 2, I get negative 4. And again, you can plug that in and confirm. All right, I'm only going to focus on the 25 and the 5. 125 and the 25. I'm not getting worried about it being a fraction. First off, I'm just going to say 5 to the 3rd power is 125, and 5 squared is 25. Now, since the 125 is in the denominator, I simply make that negative. That's all there is to it. And there's no other exponent. And this has the x plus 8. So I get rid of the 5s because I have the same base now. And so it's simply negative 3 equals, I'm going to distribute the 2x plus 16. I'm going to subtract 16, and yes, I'm going to get negative 19, and I'm going to get a fraction. Negative 19 over 2, or negative 8.5. Sorry, 9.5. Math is hard sometimes. 9 is 18 plus the 1. Either one of those right, and yes, it is correct. We can have fractions, we can have negative, it's okay. Number 4. Again, I'm just going to worry about 3 and 9. 3 to the 1, 3 to the 2. Then the 6x minus 2, and the negative x minus 1. And the only thing I got to remember is it's negative 2 to move it down here to the denominator. That's it. Same base, 6x minus 2, multiply by negative 2, which is positive 2x, positive 2. I'm going to subtract 2x. I'm going to add 2. And again, if you need to show the steps of minus 2x, add, you know whether you make those mistakes or not. All right? It is x equals 1. And that's it. Okay, identifying what's going on here. Now remember, the kid with the balloon. This is who's holding the balloon. That's the balloon. So based on this, 2 means growth. Who's holding the balloon? The 3. That's growth. Who's holding the balloon? 4/7, which is less than 1, which is decay. Domain, all of these are negative to positive infinity. There is no change here. This is easy. They keep going left and right forever. That does not change. The range, we have to look if it's positive or negative. That is positive. Okay? So it is going to be going towards positive infinity. And this tells us how low. Parentheses, because it doesn't ever cross that. It's an electric fence. All right? Negative, which means it's going towards negative infinity. How high is it going? 4. Again, never crossing 4. Never even touching it. Positive, so positive infinity. How low? -6. Transformations. The 1/3. Now here is where we look for the transformations. Not the 2. The 2 does not mean stretched. The 2 is the base. 1/3 means compressed. The x minus 3 inside lies means right 3. The +7 means exactly what we think, up 7. Number 6, the negative flips it. The 1/2, again, means compressed. The +4 means up 4. Number 7, the 4 means stretched. X minus 4 means right 4. Inside lies. -6 means down 6. All right, 8, this is growth. 10 is decay. 9 is the challenging one. People look at that and say, oh, it's going down, so it's decay. No, it's just like this, only flipped. So this is positive growth. This is a negative flipped growth. So number 9 is actually growth. It just happens to be flipped. And I would maybe make a note of that, because that one gets people all the time. All right, number 11. Okay, we have -2, -11, slightly off the chart. -1, -3, 0, 1, that's important. 1, 3, 2, 4. Okay? Remember, this is my asymptote. It will never cross this line. I like to draw that in. Okay? I'm going to post my points. -2, -11, just slightly off. -1, -3, 0, +1, 1, 3, and 2, 4. So that tells me it's going to come up like this and then right along the fence. The domain does not change on any of these. It's going left forever and right forever. The range is going down towards negative infinity. And it's going up and never hitting 5, which is also the asymptote, which is also this nice number right here, K. So that tells us everything we need to know. Y-intercept is 0, 1. Okay, number 12. We have just a few points here, 0, 3, -1, -3, and -2, -5. So 0, 3, -1, -3, and -2, -5. Not a lot to go on. The y equals the asymptote is at -6. So when we sketch this, it's coming down like so, hitting those 3 points and then riding out. Notice I slightly went over the line. You know, try to be careful. I will accept that. All right, I just won't accept this. You know, be careful. But if you slightly miss, you don't have to go back and erase it. That's good enough. I will take that on the test. Domain doesn't change. Range, it's going up towards positive infinity, which is always on the right. How low is it going? -6. Remember, positive infinity is always on the right, negative infinity is always on the left. Just like this. Okay? The y-intercept we got at 0, 3, and the asymptote is that -6. Remember to put y equals. It's a horizontal line. Number 13, we have points like -5, positive 14. We have -4, 2. We have -3, -2, and 0, -3.9. Why is that? Because my asymptote is down there at -4. So it's going to be really close to that point. Might even be hard to graph. So -5, 14. You know, it's going to be up here somewhere, obviously. -4, 2, it just kind of gives me somewhere to aim for. -3, -2, and that 0, -3.9 is going to be really close right there. So it's going to come down and then whoop, right along that fence. Okay? Again, that -5, 14 is off the chart, but it kind of gives you an idea whether to go, you know, this way or this way. You know, it just helps give you a point to aim for. It doesn't have to be exact, obviously. Domain does not change. The range is going up towards positive infinity, never hitting -4. The y-intercept is at 0, -3.9. And the asymptote is that -4, right there. On number 14. We have 5, -13, 4, -5, 3, -1, 2, 1, 1, 2, and 0, 2.5, approaching this 3, which is our asymptote. I like to draw that in again. Okay, 5, -13, somewhere down here, just something to aim for. 4, -5, 3, -1, 2, 1, 1, 2, and 0, 2.5, right about there. So we're going to come up, approach the line, and ride it on out. Does not change. Range is coming down towards -infinity on the left side. How far is it going? Up, but not crossing +3, which is also that asymptote. And the intercept is at 0, 2.5. All right, 15. I can count. It says round all answers to the nearest whole number unless they have monetary value, and then we're going to go to the nearest hundredth, pennies. All right, the value of a certain machine was purchased for $32,000. It decreases, meaning minus 7% is 0.07. So what would that function be? Future value is 32,000. 1 minus, for depreciation, 0.07 raised to the time of t. What's the decay factor? It is at 7%, 0.07. It's what you subtract from the 1. And find it after 15 years. Well, that's easy. We just write everything again. 1 minus 0.07. And then up here, we put the 15. And the answer for number 15 is $10,774.43. Check your rounding. Be careful. Number 16, there are currently 12 mice. That's that number right there. The population increases. That means I'm going to use plus. 8% is 0.08. 0.08. Now be careful. It says this is the rate for each month. What about a year from now? That's 12 months. Pay attention if these are the same unit or if you have to convert. Number 16 is going to be 30.2. We don't have a whole 31st mouse, so that's 30 mice. And be careful, even if it was 30.9, we don't have that 31st mouse. We don't round up in that case. Even though we know the rules say, oh, round up. In that case, we don't have that whole extra mouse, so we round down to 30. Number 17. In 2000, that is a distractor. Don't need it. That is just, well, we need it. Sorry, my bad. We don't need it for this value right here. We do need it to figure out how long. Sorry. Sometimes those are in there for a distractor. So, accumulated value, future value is 14,600. 1. It's been growing, plus. 2.8% is 0.028. Where will it be in 2025? That's 25 years. Plug that in, run the numbers, and we get 29119.3. So we round down again. 29,119 people. 18. 90 degrees is our starting temperature. We're starting at time 0. If stirred steadily, the temperature decreases, that's minus, at 1.7%, that's 0.017. So that's 1 minus 0.017. Find it after 15 minutes. When we're starting at 0, that's a total of 15 minutes. When we type that in, we get 69.6 degrees. Now, no, this is not a money problem, but a temperature we can put around a decimal. If you did round that to, 70 degrees, I would understand that. But with money or like temperature, we can use a rounded decimal. Number 19, we're beginning with one view. Okay, one view. It goes viral and it increases. So that's 1 plus. 6.2, 0.062, 0.062. See how these numbers coordinate? But that's per hour. And we're going to ask about 1 week. So you have to figure out how many hours are in a week. Well, there's 24 hours in a day and there's 7 days in a week. So 24 times 7 is the number we plug in. And again, we can type it in just like that. It will do the math for us. So number 19 is 24,486.1. So again, you would have rounded down anyway. But just a reminder, if that was 0.9, we would still round down to this. Number 20, identify the important information. The initial investment, that's the 14,500. That's A. The interest rate is 6.2%. Move the decimal 2 places to the right this time. Number of compounding periods, that's this number. Now be careful, time of investment is not 48. Remember, this number is 4 times the number of years. Okay? It was already calculated for you. So that would be 4 times 12 is 48. And the accumulated value, if you run that through the calculator, you will get $30,339.23. It would actually be 0.228. The 8 tells the 2 to round up. 21. A saving account offers 1.7%. That's 0.017. Compounded. That means we're using the other formula. So future value, we're putting in $250. We're going to do 1 plus, because there's no decreasing compounded. There's no decay. But remember, that 0.017 goes on top this time. Compounded weekly, there's 52 weeks in a year. That number goes there and there. Make a note of your cheat card, how this works, and then 18 years. So we put times 18. We don't have to calculate this separately. We can just type it in that way. And for 21, we get $339 and 0.478. This rounds that up. So $339.48. 22, $1,300 initially. 1 plus compounded monthly, 0.043 goes on the top. It says monthly, so that's 12 here and 12 there. 7 years times 7. Run the numbers. We get 1755.6. Sorry. I said it but didn't write it. 1755.627. This rounds that up to 1755 and 63 cents. Last but not least, we have two options, option A and option B. They're both compounded, so we're going to have the initial investment of $5,000 for both. So for option A, it's 6.5%, 0.065. 0.065. Option B is 4.2%, 0.042. Option A is compounded quarterly. That's 4 times a year, 4 times a year. Option B is monthly. That's 12 times a year. That's 12 times a year. 10 years, 10 goes here, 10 goes here. So this is 40, and that's 120. When we run the numbers, we end up with $9,527.79. And over here, we end up with $7,604.23. That means option A is the winner. And that's it.